Hi girls, welcome back to calculus in a way, I guess. I feel like I haven't seen you guys forever, but hope you're staying warm and safe. So we've got a lot to cover. First, what I'd like to do is I've got a little summary page here of the notes that we did way back when, last class. And then I've got the homework answers. I wanted to talk you all through some of those. And then I've just got a little bit of new stuff for today. I didn't go too crazy on that. So anyway, first of all, here's kind of a summary of the notes that we did last Monday, I guess, a week ago Monday, about finding the relative max and mins from the equation. So I'm just going to kind of walk through these and then we'll go over some homework. So first of all, when you're given a function, you want to look at the domain of it, find if there's any values that again are excluded from the domain, but we'll look at that later. Then you want to take the derivative of it, find the critical points, and remember the critical points are where the values that make the derivative 0 and the values where the denominator is 0. So those are the critical points, remember, and then we graph those on a little number line, and then we plot those on a number line, and then we determine increasing or decreasing for each interval. And remember, to do that, we choose values in between the intervals and plug in to the derivative. And then we determine min or max for each point. Remember, because when we've determined increase or decreasing, we've determined like positive or negative. And the max or mins refer to what's happening at each point. Well, if it's increasing and then decreasing, then we know that's a max. If it's decreasing and then increasing, then we know that's a min. Okay, so again, just a little refresher here. And then to actually determine the min or max for each point, we plug it back into the original equation. Okay, so to actually say this is the max value or this is the min value for the function, we plug that into the original function. Okay, so again, hopefully that brought back some memories for you. So let's look at how we did that on homework. So this is the homework. I will check it again or just verify that you did it next class, but this was the homework that was due today. So 1 through 7 was just looking at graphs and determining relative mins and maxes based on a sketch of the graph from the homework. So here's those answers. 15, 17, 19, 23, and 25, we're actually looking at equations and coming up with the mins and maxes. So actually all of this will be posted again on, these completed notes will be posted on OneNote for you to look over these thoroughly, or you can pause me right here. But again, 1 through 7, we're looking at graphs. 15, 17, 19, 23, 25, and 27, we're looking at equations. Now, rather than walk through each of these in detail, I have worked out 19, let's see, which ones did I do? 19, 23, and 25. And again, those will also, you can see these through the notes here in a little while, or let's kind of walk through those a little bit now. So if we look through number 19, so here's the original equation, x to the 4th minus 18x squared minus 4. Took the derivative, set the derivative equal to 0, and solved it. So we got 0, 3, and negative 3. Those became our critical points. So we graphed those on our number line, right? And now we created 4 intervals. We created an interval from negative infinity to negative 3, negative 3 to 0, 0 to 3, 3 to infinity. So again, we choose numbers in those intervals and plug them into the derivative and find out positive or negative. So here we chose negative 4. We found out that was negative, so it's decreasing in that interval. Plugged in negative 2. Found out it was positive, so it's increasing on that interval. So that makes negative 3 a minimum because it's decreasing until it gets to negative 3, then increasing, so negative 3 is a min. Plugged in negative 1 for the next interval and got a negative, So that means 0 is a max because it's increasing on the way up to 0 and then decreasing. So 0 is a max. Plugged in 4 into the derivative and got a positive. So that means it's increasing from 3 on. So 3 is a min because it's decreasing on the way in and then increasing. So 3 is a min. So now we know we have a min at 0. No, I'm sorry, we have a max at 0. And we have a min at 3 and negative 3. Now to find the ofs, or to find out what the actual max is at 0, we plug it into the original. So f of 0 equals negative 4. So we have a max at 0 of negative 4. We have mins at negative 3 and 3. We plug those both into the original equation and make it negative 85. So our min is at 3 of negative 85 and at negative 3 of negative 85. Okay? Let's take a look at 23. So again, 23. Here's the original equation. And we took the derivative. Okay, now, one other way to find critical numbers is where the equation equals 0, but also what makes the equation undefined. So anytime you're looking for what makes an equation undefined, you're looking for x's in the denominator. And here, when we took the derivative, we created an x in the denominator. So since it's just x to the 1/3, the value that would make it 0 is if x equals 0. So therefore, 0 becomes a critical number. We also now need to set the derivative equal to 0 and solve. And that is this over here. And that ends up to find the value of negative 1. If we set the derivative equal to 0 and solve, we get x equals negative 1 as another critical number. So we have two critical numbers, negative 1 and 0. That creates 3 intervals that we have to check for increasing and decreasing. We plug in negative 8 for this first interval, and again, I chose negative 8 because I knew I was going to have to take a cube root of a number, and negative 8 is a perfect cube. So I plugged it in, I found it's positive. So it's increasing on the interval from negative infinity to negative 1. Between negative 1 and 0, I chose negative 1/2. I plugged that in on my calculator, and I got negative 5.2. So it's decreasing on that interval. I plugged in 1 for the third interval, and I found that equals 4, positive 4, so it's increasing. So again, if it is increasing coming up to negative 1 and then decreasing, negative 1 is a max. It's decreasing coming into 0 and then increasing, so 0 is a min. So I have a max at negative 1, excuse me. I have a max at negative 1. I plug negative 1 into my original function, and I find that it is a max at negative 1 of 1. I have a min at 0. I plug 0 into my original function, and it equals 0, so the min is at 0 of 0. Okay, hopefully that is sounding familiar to you guys. Here's number 25 worked out also. I'll let you guys look at that, but 25 comes out to be actually no real solutions because we ended up taking a square root of a negative number. So there's no solution, no extrema. Okay, so what we're going to do today is really not going very farther than that. We're just going to find these increasing and decreasing intervals and the relative max and mins and sketch a graph. Okay, so it's really just practice of what we've done so far. I didn't want to go too far without us being in class. So let's try some. Okay, so we want to sketch the graph of this function using the function itself and the derivatives. So first, let's just take a derivative. So we take this derivative, we get 3x squared plus 6x, and the 1 goes away. So now again, we look for, is there any values that aren't defined in the domain of this function? And no, because there's no x's in the denominator. So to find critical numbers, we just want to set it equal to 0. So to solve that, we can factor it. So we can take out a GCF, we can take out 3x, and we're left with x plus 2. Now we set each of those equal to 0. and solve further, and we get x equals 0 and x equals -2. So now on our number line, we know we have critical points in -2 and 0. Again, so now we pick values in those intervals and plug them in to see if they're positive or negative in the derivative. So let's choose -3 for this first interval. It has to be less than -2. So if I plug -3 into my derivative, and I'm going to use the factored form because it comes out easier when you're just looking for positive and negative, that becomes -9 times -1, which gives me a positive. That's all I really care about, is whether it's positive or negative. So it's increasing on that interval. Now to check this next interval between -2 and 0, I'm going to just choose -1. So I plug -1 into the derivative, and I get -3 and +1. Again, I'm plugging -1 in to factored form, and I get, and that becomes a negative. A -3 times a 1 is a -3. So it's decreasing on that interval. To test the last interval, I'm going to choose +1 because it has to be just greater than 0. So if I plug in +1 into the factored form, I get 3 times 3, which is +9. Okay, so there again, I find that since it's increasing, approaching -2 and then decreasing, then I know -2 is a max because it's going up and then down. So this is a max. And at 0, it is decreasing on its way to 0, then increasing, so 0 is a min. So I have a max at x equals -2, and to find out what that max is, I'm going to plug in -2 to the original equation, and if I plug in -2 into the original equation, I get -2 cubed is -8, plus 3x squared is going to be 12 plus 1. Shoot. And that equals 5. So -8 plus 13 is +5. So my max is at -2 of 5. So that's going to create a point on a graph of -2, 5, which we'll get to in just a second. Okay. Now, my other critical number was 0. So I know, and we know we have a min at 0. So a min at x equals 0, we need to find the of. So to find the of, we're going to plug in 0 to the original equation. And again, if you come up here and look at the original equation, if you plug in 0, you just end up with a 1, right? Because this goes away, that goes away. So f of 0 is 1. So we have a min at x equals 0 of 1. So that also is going to turn into a point on a graph of 0, 1. So now to sketch the graph of this function, again, these are just very primitive sketches. We're going to plot these 2 points. So let me give us some values here. Okay, so we want to plot the point. Okay, so we want to plot the point 0, 1. So 0, 1 would be right here, and it's going to be a min, and -2, 5 is going to be -2, 5 right here. And we know that as it's approaching -2, 5, it's increasing, and then it's decreasing. So it's increasing as it gets to -2, and then it's decreasing until it gets to 0. And it's decreasing as it gets to 0, and then it tells us it's increasing. So decreasing as it gets to 0, and then increasing. So here we've sketched the graph. It has a max at -2.5 and a relative min at 0.1. Boom, that's it. Okay? So again, we haven't really added any math other than what we did last class. We've just now used that information to make a sketch of the graph. Okay, so let's try another one. Okay, so this one's a little bit different, it's a little bit more complicated, x to the 4th. So first thing we're going to do is take the derivative, and we get 4x to the 3rd minus 16x, and the 9 goes away. So again, this is a polynomial. There's no values that make the derivative undefined, so we don't have to worry about that. We just have to set it equal to 0 and solve. This is another one. To solve it, we can take out GCF. So we can take out a 4 and an x, and we're left with x squared minus 4. See, does that make sense? Yeah. So now we set each of these equal to 0. 4x equals to 0 gives us a critical value of 0. X squared minus 4 equals to 0. Again, you can think about this as x squared equals 4. So x equals the square root, which is plus or minus 2. Okay? You also, at this point, could have thought to factor that as x minus 2, x plus 2, set that equal to 0, and you still would have gotten plus or minus 2. So either way you looked at that. Okay, so now, if we look at our critical numbers, we have -2, 0, and positive 2. And that, again, came from setting our factor form equal to 0, and we got our critical numbers. Okay, so now we have 1, 2, 3, 4 intervals we have to find increasing or decreasing for. So I'm actually going to, so we can see all of the work, I'm going to come up here and do this. Okay, so let's plug in a value less than -2 into our derivative. So I'm going to choose -3. And again, I'm plugging it into our derivative here. So that's going to give me -12. And the -3 squared is 9, minus 4 is 5. So that gives me a negative number. So this is decreasing. Between -2 and 0, I'm going to plug in a -1. I plug that in, I get -4. And the -1 squared is +1, minus 4 is -3. Gives me a positive 12. The next interval, 0 to 2, I'm going to plug in a +1. That makes 4 times 1 is positive, and 1 minus 4 is -3. So that gives me a negative, so it's decreasing. And then outside of 2, greater than 2, I'm going to just choose +3. So you can kind of see a pattern here. And I get positive, again, plug it in into a factored form over here. I get 12 and 5, so positive. So you can't always depend on this changing of negative to positive, but on polynomials it does usually happen. So we've got, so here we have it decreasing and then increasing, so that makes -2 a min. And then it's increasing and then decreasing, so 0 is a max. And then it's decreasing and then increasing, so 2 is also a min. So now we have, let's start with the max. We have a max at x equals 0 of, and if we look up here at our original equation, and if we were to plug in a 0, then we just get a 9, right? Because the x values go away. So of 9. And so that gives us a point we know we're going to have of 0, 9. And now we have mins at x equals -2 of, so we need to find f of -2. And if we come up here to our original equation, we plug in -2, -2 to the 4th is going to be 16. And it's going to be a positive 16. And then minus -8, let's see. Okay, actually, as I was talking through this, I realized when I did this with C block, there was a lot of confusion about what actually is the value of f of -2, because it's really tricky to plug in. So I want to do that with you guys on my calculator. So I'm going to plug in, again, I'm up here with the original function, just trying to find f of -2. So on my calculator, -2 to the 4th, I've got to put that in parentheses. That's the biggest mistake everybody makes in plugging in numbers. So -2 to the 4th, and then minus 8, and then times -2 squared, and then plus 9. So I hit enter, and it is -7. So down here, f of -2 equals -7. I also have a min at +2. And again, to find the of, or the value for that, I'm going to plug in +2 to the original equation. So let's go back up here to the original equation. Now I'm going to plug in +2. So again, I'm still going to use parentheses. It's not as critical in a positive number, but it's just good practice. So f of 2 to the 4th minus 8 times 2 squared plus 9. And I get +7. So down here, I have f of 2 equals 7. So again, I have a point at 0, 9, a point at -2, -7, and a point at +2, -7. Yeah. Okay, so now, again, I'm just going to make a simple sketch of my graph. And I know I need the points. Oh well. Okay, so I want to sketch 0, 9. So let's go 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7. So again, this is a very crude sketch. But again, to sketch the graph, these are the points I need. 0, 9, so that's up here. -2, -7. +2, -7. Now I know that mins are happening at the -2 and +2, so a min means it's decreasing and then increasing, and a max is increasing and then decreasing, decreasing and then increasing. So again, I've just connected the dots by using the number line that we sketched up here. So I know it's going down until it gets to -2, then going up to 0, then going down, then going up. Okay, so we're really just using the information we found to sketch a graph. Okay, I've given you guys 2 of these to do for homework, and it's on a worksheet that's posted on LMS. Okay, so that's the first 2 problems. Now, this next section, the next thing we're going to look at is very similar, and I think it's easier, but some students might find it confusing. But now we're going to do the same thing. We're going to sketch a graph, but we're not going to have an equation to go off of. We are just given the information that you would find if you had an equation. For instance, whatever our equation is, we don't know what it is, but we're told that the derivative at 1 and at 4 is equal to 0. So what can we do with this information is if 1 and 4 are the values that make the derivative 0, then we know that 1 and 4 are the critical numbers. So again, we're just using those values on our number line. Okay, next we are told that the derivative is greater than 0, okay, or positive when x is greater than 1 and less than 4. Okay, so what this tells us, if the derivative of f of x is greater than 0, that means it's positive between 1 and 4. So that just means it's increasing between 1 and 4. When we're told that the derivative of f of x is less than 0, that means it is negative when x is less than 0. So we got a negative here. When x is less than 1 and when x is greater than 4. So again, these two lines were just meant to give us these values, the interval values. It's positive between 1 and 4. It's negative less than 1 and greater than 4. Okay? So now, looking at this, we know that 1 is a min, again, because it's decreasing then increasing, and 4 is a max, because it's increasing then decreasing. Okay, this tells us our point values. So this is saying at 1, when x equals 1 in the original function, y is negative 2. When x equals 4, y is 1. So that gives us enough to sketch our graph. So we need a point, let's see, we need a point 1 and 4. Let's see, a little more values here. So now we need 1, negative 2, and 4, 1. And now we know it's decreasing until it gets to 1, and then it's increasing, and then it's decreasing. Okay, so again, we just basically sketched a graph, just being told about the derivatives. 1 is a min on our graph, there's a min at 1. 4 is a max on our graph, there's a max at 4. The intervals tell us what they should be doing. Decreasing until you get to 1, then increasing, then decreasing. Okay, let's try another one. Okay, again, let's look at this one. This information gives us our critical numbers, and this is the same on all of these, so I don't try to trick you all messing with the order here. But if the derivative at 2 and at negative 3 equals 0, that's telling us our critical numbers are positive 2 and negative 3. Okay, again, now this piece is telling us that the derivative is less than 0 or negative between the two numbers. So that means it's decreasing between the two numbers. The derivative is positive, greater than 0, when x is less than negative 3 and greater than negative 2. So that's telling us that it's positive when x is less than negative 3 and when x is greater than 2. The biggest problem I found with students here is you're not real sure of yourselves on the less than and equal to symbols, which that again, it just takes practice. But f of x is greater than 0, that means positive, right? And x is less than negative 3 means over here, and x is greater than 2 means over here. So it's increasing at those intervals. F of x is less than 0, again, that means negative or decreasing, and this notation, which we've seen several times, means greater than negative 3 and less than 2, which means in between. Okay, so now we know our graph. We're going to have an x equals negative 3 and x equals positive 2. We're going to go up to 4 and down to negative 2. Okay, so now we know we have a point of negative 3, 4, based on this information, -3, 4. And we have a point 2, -2 based on this information. So we know this should be a max, again, because it's going up and then coming down. So we should have a max at -3, decreasing and then increasing. This should be a min. So we're increasing and then decreasing and then increasing again. So we sketched our graph. Okay? All right, so again, you can review this, replay this video. I'm sorry it took so long, but it's hard to explain quickly. Your homework is again, it's a worksheet with this title on LMS in the file section. The first 2 are sketching graphs from the equation. The last 3 are sketching graphs like we just did here. Okay? I hate that I have not seen you guys in over a week, so do the best you can on this. We'll take plenty of time on Friday and go over it, but definitely have tried it yourself, because again, it's better to hear it for the second time. Stay safe and warm out there, and hopefully I will see you on Friday. And I will be available really all day. I'll be checking in and out on emails, so I apologize for this getting posted a little bit late. Hopefully you guys aren't sitting here waiting for it, but yeah, email me if you have some questions. Otherwise, I'll see you Friday. Thanks. Bye.